we made these nanoemulsions. People call them liposomes, but it's more technically a nanoemulsion of hemp oils. And we said, oh, wow, these things are really good. They really relax you. And some of the early data that we looked at, it was CBD as an anxiolytic. And so I was like, okay, it's good for that. And people talked about it for cancer. People talked about it for pain. But when we really got into using it in the context of what we do, which is detoxifying people, purifying, cleaning them out, the hitches that we would often find when we're trying to detoxify people are neurological hitches, specifically neuroinflammatory reactions. Anyone with multiple chemical disorders, anybody who's had Lyme disease or mold toxicity will know that they try some new therapy and the first thing they get is brain on fire. They get neuroinflammatory problems. And it can be brain fog, it can be anxiety, and sometimes they don't even really feel it. But this is a phenomenon that happens mostly around the glutamate receptor, and you get hyperexcitability of the glutamate receptor, and that can cascade throughout the autonomic nervous system and cause dysfunction anywhere in the body. As we got to use CBD in our protocols for detoxification or for treating Lyme or mold, we found that its greatest utility was in settling down the neuroinflammatory reactions that people were having. And when we settled that down, the whole system settled down with it. The autonomics came with it. You'd find people, oh my God, I'm trying to detox them from mercury. They have this chronic kidney stress. So you give them kidney supplements, but it doesn't stop it. You lower the dosage of the detox supplements, and that lowers the pain, but it doesn't detox them. And then we found that it was actually all cascading down from the brain. You had to settle the reactivity in the brain before the body could release and let the healing happen. That is why I say that this is possibly the most important supplement for harmonizing biomedical therapies. All right, so we're going to talk about the endocannabinoid system. And the first part of this is just to let us know, hey, the body was meant to deal with cannabinoids. One of the greatest parts of your neurological system that settles a balance between neurotransmitters and immune function is the endocannabinoid system. So we're going to talk about that for a second. Then we're going to talk about phytocannabinoids, the way we can supplement for the endocannabinoid system. Then we're going to talk about the brain on fire aspect, CBD, glutamate excitotoxicity. This is when the glutamate receptors start becoming hyperactive. This is why you have a lot of these children on low glutamate diets or low glutamate stimulating diets. Because it's not necessarily just that they have a massive level of glutamate in their brain, it's that the receptor that's reading that is hyperactive. And that is causing neuroinflammation. Then we're going to talk about what people don't talk about enough, and that's the second part of why CBD works so well, and that is gene transcription modulation. If you ever see me talk about detoxification, I'm talking about upregulating a set of genes for detoxification through a trigger called NRF2. Goes into the nucleus and turns on all the genes for chemoprotection. There's a lot of plant compounds that do it. And one of them is cannabidiol. And some of the other cannabinoids do this as well. So we have something that can calm down the negative effects of these therapies by calming down the central nervous system hyperexcitation, and at the same time can turn up the processes of detoxification, of free radical control, of repair and regeneration. And then we'll talk about a delivery system and how we deliver cannabidiol and why it has such a high bioavailability, and we'll look at it compared to some pharmaceutical bioavailabilities. All right, so just an idea of the endocannabinoid system. It might be easy to get into this frame of mind where you think that the brain evolved somehow with cannabis plants, and they have some symbiosis together. But the cannabinoid receptors actually evolved long, long, long before the cannabis plant did. In fact, the endocannabinoid receptors, there's one called CB1 and CB2, existed in all primates. In fact, as far as 600 million years ago, we had organisms with cannabinoid receptors. So everything except insects and nematodes and hydra, anything that's a vertebrate has cannabinoid receptors. So they've been there for a long time, and that means that thus we have cannabinoids that we make inside of us. So 600 million years ago, we had an endocannabinoid system, and the cannabis plant evolved approximately 25 million years ago. So this is a plant that makes chemicals that work with our endocannabinoid system. The endocannabinoid system will look at the receptors and what they mediate, but they mediate a lot of neurological function, a lot of central nervous system function, and a lot of peripheral immune function. So the classical endogenous cannabinoids, the two major ones, one is called anandamide, or the bliss molecule, and this is a little bit more of a central nervous system one. And then there's one called 2-arachidonyl glycerol, and this one is a little bit more towards the CB2 or peripheral receptors. But you see those two molecules there, they're very similar. And these are ones that you make in your brain to have controls over neurologic function and its interaction with immune function. So endogenous means it's made by the body, and these cannabinoids have two receptors that they dominantly work on, the CB1 receptor and the CB2. The CB1 is a central nervous system receptor, and the CB2 is predominantly peripherally in the immune system and the organs, but it's more of an immune regulating one. So in the brain, in the basal ganglia, you've got movement effects related to the CB1 receptor. You've got it through the cerebral cortex, the hypothalamus, the hippocampus, the spinal cord. So most of the functions of the brain do have some regulation from this endocannabinoid system. Now, the peripheral CB2 is even vaster in all the different effects that it has. So each one of the organs has CB2 receptors, and the relationship of the CB2 receptors to the cannabinoids controls multiple different functions within the body. So I don't want to focus too much on those. I'd like to spend more time on the brain. But just to follow up on the endocannabinoids, anandamide, first discovered in '92 by the iconic now Professor Meshulam. Ananda is Sanskrit word for bliss. It's something that's found in chocolate. It's something that's produced during meditation, and it's thought to be responsible for runner's high. So the CB1 receptor, the one in the brain, is responsible for more of the psychotropic effects of cannabinoids. So THC dominantly hits the CB1 receptor. The CB2 receptors are more related to control of cytokines and inflammatory responses, modulating the immune system. 2-arachidonyl glycerol is synthesized from omega-6 and is more of a CB2 type receptor. They found it in animal milk and human milk. And we don't have to spend much more time on that. But they all have receptors at the synapses, and they're involved in the dance of how all of your neurons communicate together.